So in this video we'll try to implement the bubble sort algorithm. We have already seen some examples of bubble sort algorithm in the preliminary course. So here we'll try to implement the bubble sort function in the C programming language. Okay, so what is a bubble sort function? Assuming that we have an array like this and we want to sort all the elements which are present inside this array, and assuming the type of sorting which we want to do is it will be the non-decreasing order. Okay, for example, if we have the elements which are 5, 0, 1, 7, and we have 3 and 2, assuming that these are the elements which are present inside this array. Now, as I told you in the bubble sort algorithm, that in case of bubble sort we perform two types of operation. Number one, we are going to perform some passes, and number two, we are going to perform some iterations. So there are two things. Number one is passes and second one is the iterations. So we'll be doing passes and iterations in for example, if there are total n items in this, then we are going to do total n minus 1 passes, and at the same time we are also going to do total n minus 1 iterations. And later on we proposed one more algorithm, which was the improved bubble sort algorithm. So the main purpose of this program is not just to implement the bubble sort algorithm, but rather implement the bubble sort algorithm and implement the improved bubble sort algorithm and compare these algorithms on the basis of the time complexity for these functions. And here the time complexity that we will be taking will be the actual running time of these algorithms, rather than just the time complexity of discussing the number of statements which are being executed. We are going to discuss the time complexity on the basis of actual running time of these algorithms, and we are going to take an array which is having large number of elements. For example, we'll be taking an array which will be having 1000 elements. Okay, so let us see how the bubble sort algorithm can be implemented. So initially we are going to compare these two elements which are 0 and 5. If 0 is less than 5, so we are going to swap it. 0 will come here and 5 will come here. After this, the elements that we will be having is 0, 5, 1, 7, 3 and 2. Now in these elements, then we are going to compare the elements which are 5 and 1. Now 1 will come here and 5 will come here. Later on, again after this operation, the elements that will be having is 0, 1, 5, 7, 3 and 2. Now here again we are going to compare 5 and 7. Now you can see 7 is greater than 5, therefore there is no need to swap the elements. After this, the element that we will be having is 0, 1, 5, 7, 3 and 2, and we are going to compare 7 and 3. So because 3 is less than 7, so 3 will come here and 7 will come here. Again the elements will be 0, 1, 5, 3, 7 and 2. Again we are going to compare the element which are 7 and 2. Because 7 is less than 2, so because 2 is less than 7, therefore 2 will come here and 7 will come here. Now you can see this entire is a first pass. After the end of the first pass, the biggest data is at its correct position. Now you can see if the biggest data is at its correct position, therefore if there are total n items, so we have to perform total n minus 1 passes so that all the n minus 1 data will be at its correct position. So obviously the nth data will come at its correct position. And in this complete pass, these are the iterations. This is iteration number 1, this is iteration number 2, this is iteration number 3, this is iteration number 4, iteration number 5. Because there are 6 elements, so we have 5 iteration in this pass. So this is the bubble sort algorithm. We already discussed this algorithm before in the preliminary course. So I'm just going to implement this bubble sort program here, and then we'll implement the bubble sort program. We'll try to analyze what is the actual running time of this bubble sort program. Okay, so for this purposes, we'll be taking two loops. So for that we will be having integer I, j, and we are going to take an extra variable which is the temporary variable. Now we'll be doing for I is equal to 1, I less than n, and we'll be having I plus plus. Now here you can see n is the total number of elements and a is the array. Then we'll be having next for loop, which is for j is equal to, we can take j from 0, so j is equal to 0, j less than n minus 1, and we'll be having j plus plus. Now you can see the I loop will run n minus 1 times. At the same time, the j loop will also run n minus 1 times. Now we'll be putting a condition here that if the element which is present in a of j minus 1, a of j, is greater than the element a of j plus 1, then we'll swap these elements. For swapping, we can use a temporary variable, so we can do temp is equal to a of j, and then a of j is equal to a of j plus 1, and then a of j plus 1 is equal to temp. Okay, and by this we can perform the bubble sort function. This is a very simple function. We have already seen the example. Nothing can be simpler than this. So first of all, let us test out this function and we'll see if this function is working correctly or not. Now if this function is working correctly, then we implement this function in a bigger array, maybe an array which is having 1000 elements, or maybe an array which is having 10,000 elements, and then we'll try to see what is the actual running time of this function. Okay, for actual running time, we are going to use the header file which is hash include time.h. We'll take that one by one, don't worry. So let us first of all try to implement this bubble sort function on a simple array. Okay, so we'll be taking an array, integer, assuming the name of the array is ARR, and let us assume we are having 10 elements only, and these elements are in decreasing order: 8, 7, 6, 5, 4, 3, 2, 1, and we'll be having an element which is 0. These are total 10 elements. Now we are going to call the bubble sort function, bubble sort, on this array, and there are total 10 elements, and after this we can just print out all the elements which are present in this array, because bubble sort is going to sort these elements. So I'm going to take an extra variable integer I. Now for I is equal to 0, I less than 10, I plus plus, I'm just going to print these values. That is, printf will be having ARR %d comma ARR of I, and we have done this work just to see that whether this array is sorted or not. So let us go to build, and we are going to run the program, build and run. Now you can see the array is now sorted. Array is having the elements which are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. And this is a very simple proof that this function is working perfectly. There is no issues whatsoever. Now what if there are some elements which are repeating? For example, here we are having 9, and here we are having one more element which is 0. If the elements are repeating, is it working perfectly? Let us see. So see if even if the elements are repeating, this function is working perfectly, and it is giving the data in sorted format. That's okay, because it is very simple, right? Now what we are going to do is, we'll take an array which is having 1000 elements. We'll be having 1000 elements in that array, and we'll try to measure the actual running time of this bubble sort function. Okay, so we are going to take integer ARR which is having 1000 elements, and we are going to put elements into this array in decreasing order. So for, we'll take one more variable, integer I, for I is equal to 0 and I less than 1000, and we'll be having I plus plus, and then we are going to put ARR of I is equal to 1000 minus I. Okay, so this is putting the elements in reverse order. For example, the 0th index location we are going to put 1000 value. In the first index location we are going to put value which is 999. In the second index location we are going to put the value which is 998, and so on. And now to measure the time, we'll be using the header file which is hash include time.h. So hash include time.h. Now this time.h header file gives us the facility to include some functions which are related to the time. For example, we can find out what is the current time and what will be the time after execution of the function. So that is just, we are just going to store the clock, and we'll measure the time. We'll find out what is the difference between the two clocks before executing the function, after executing the function. For that purposes, we are going to take a variable here which is that is, we are going to take clock underscore t. So for this we are going to take two variables of clock underscore t type, that is start and end. This start variable will take the value in the beginning, that is what was the value of the clock before starting the function, and this end variable will take the value is what is the value after ending the function. So I'm going to take start is equal to clock. So that is what is the exact time before starting the function, bubble sort. And end again is equal to clock, that is what is the exact time when you are ending the function. And then we'll measure the difference between the start and end, right? For example, right now if it is 4 or 10 p.m. and before starting the function if it is 4 or 5 p.m. then the difference is 5 minutes. So we are just going to measure the difference and we are going to store the difference in a double variable. So I'm going to take double CPU time used. This is a variable which will tell what is the CPU time used to execute this function, and which will be will be using double and minus start. Okay, and this value will be stored, but we have not converted this value in a millisecond format. So I can convert this value in millisecond format, but before that we are just going to see what is the value of this one. So I'm going to use the printf function. Printf will be having %lf, that is long float, and then we are going to use CPU time used, and we'll try to print this value. So I'm just going to build and I'm going to run. Now you can see this giving the time which is 000000. It is not giving an exact time. Why? We are going to convert this value for clock, that is in seconds. So you can say we are going to divide it by clocks per second, and let us see what will be the value after this one. So I'm going to do build and run. So still it is taking a value. Okay, so why it is taking this much value? Because we have not changed this value. We are just sorting first 10 elements. Rather than sorting first element 10 elements, we have to sort the 1000 elements. So this is the reason why it is giving a time which is 0. Now because to sort 10 elements it is going to take very small time, which is negligible, but to sort 1000 elements it is going to take some time, and we are going to measure that time. So I'll go to build and I'm going to build and run. Now you can clearly see it is giving me some time, and this time is 0.003 seconds. Remember, it is in seconds. So we are getting the time in terms of second. We have to convert this time in terms of milliseconds. Okay, so what I can do is I can multiply it with 1000, and I'm going to say this much milliseconds. This much milliseconds it will take. So I'm just going to build and I'm going to run. Now you can say it is saying that we are going to take 3 milliseconds to sort 1000 elements if you are going to use the bubble sort algorithm. Okay, now you can see it is very simple to measure the starting time and ending time of the function. Okay, but still it is just an approximation time, because this time will change from system to system. For example, if you are going to use some other CPU which is if that CPU is slower than this one, then maybe it will take more time to sort these data items, or maybe if that CPU is faster than my current CPU, then maybe the function is going to take less time to execute. So this code will be available with you in a file. So when you execute on your system, you can measure what is the exact time this function is going to take to sort 1000 elements. Okay, now what we are going to do is, the main purpose for this video is to write the bubble sort function as well as the improved bubble sort function, and to measure what will be the gain if we use the improved bubble sort function rather than the bubble sort function, right? Because we've suggested some improvements in the bubble sort function, so we propose an improved bubble sort function, and so that we can reduce the time complexity, and we'll see how can we reduce the time complexity with this function. And later on we are going to compare this bubble sort function with other functions also, like we have the quick sort algorithm, we have the merge sort algorithm. We'll take those algorithms and we are going to compare the time complexity of those functions, or you can say the actual running time taken by those functions with the bubble sort function. Okay, so let us make an improved bubble sort function, and this improved bubble sort function, we have just done small changes in the bubble sort function. So I'm just going to copy this bubble sort function here. I'm going to do copy and paste to implement the improved bubble sort. Okay, so for this purposes I have copied this one, and the bubble sort I'm just going to write improved bubble sort function. And in this improved bubble sort function we proposed two changes. Number one, to include the flag variable, and second one, to reduce the number of iterations when we reduce when you actually sort the data. That, for example, the first pass you have to sort n items, and the next part you have to sort n minus 1 item, in the next pass you have to sort n minus 2 items, and so on. That we already discussed. So I'm just going to take a flag variable, integer flag is equal to 0 or flag is equal to 1. This is a flag variable, and here I'm going to use and flag, and as soon as we enter this loop I'm going to make flag is equal to 0, and again I'm going to make flag is equal to 1 inside this loop, so I'm going to make flag is equal to 1. Okay, if there is a swap then only we'll make flag is equal to 1, otherwise not. Okay, and secondly, the second operation that we needed to perform is to reduce the number of iterations in the pass. So for that purpose I'm going to write j is less than n minus I, so that will reduce the number of iterations in the pass. Now this is the function which is the improved bubble sort function. So we'll write, we'll copy the similar kind of same program, and but we are going to implement this with the improved bubble sort function. So this is I'm just going to make a small changes here. So the here printf statement, this is in millisecond with the bubble sort function. This is the time taken with the bubble sort function, and then I'm also going to find what the time taken by the improved bubble sort function. Okay, so for that purposes I have to initialize the array with the same values. So I'm going to just initialize the array with the same values with this code, and after this one I have to again I have to find the start clock and the end clock before starting the improved bubble sort function. So I'm just going to find what the start clock and end clock, and I'm just going to do improved bubble sort function, and then again I'm going to find what the CPU time used after this improved bubble sort. So I'm just going to find what the CPU time used after this improved bubble sort, and then in the end I'm just going to print these values in terms of milliseconds. So this time used with the improved bubble sort function. Okay, now I think you got it what I've done. So this is the code that I've declared an array. Here I've declared initialized the value in the decreasing order, and here I've implemented the bubble sort function. Before implementing the bubble sort function, I am measuring what is the current time. After implementing the bubble sort function, I'm measuring what is the current time, and by finding the difference of that time, I can find what is the time taken to implement the bubble sort. Okay, and I'm printing that value. Later on, again I initialize the same array with the same kind of values, and here this time I'm implementing the improved bubble sort function. I implemented the start of the clock, end of the clock, found the difference, and then again I'm trying to print what is the time taken to implement the same sorting algorithm with the improved bubble sort. So let us build, and we are going to run the program. Now you can see here clearly for the bubble sort function it is going to take 3 milliseconds to execute, and for improved bubble sort function it is going to take 2 milliseconds to execute. And it is very clear that with improved bubble sort function we have done some changes. We improved the time complexity for this function. Okay, so obviously clear that it isn't, but this entire thing will be more drastic if the data is already sorted. Okay, now for example, if the entire values inside the array is the same value, now as you can see I've already discussed it with you. Let me write it again. With the bubble sort function, with the bubble sort, if this is in the best case, in the worst case, and in average case. In best case it was taking omega of n square time, in the worst case it is taking order of n square time, in the average case it was taking theta of n square time. But when we proposed the improved bubble sort, now in case of improved bubble sort, in best case it was taking omega of n time, in worst case it is taking order of n square time, but in average case it is taking order of n square time. That means the best case of improved bubble sort is way better than the best case of the bubble sort algorithm. So if you want to see this change, that if the improved bubble sort is better than the bubble sort algorithm, then we have to analyze the best case of this. That means what is the best case time complexity, or what is the time taken by this algorithm in the best case. So I'm just going to store all the values which are same here, and here also I'm going to implement all the values which are same. So if you change all the values which are same, or if the values which are stored in the array they are in increasing order, or you can also store it in increasing order, that is a of I is equal to I, and here also I'm going to make a of I is equal to I. If all the values are sorted in increasing order, in this particular case the bubble sort algorithm will take order of n square time, but improved bubble sort algorithm will take order of n time. So the difference between sorting these two things will be more drastically improved bubble sort will take more drastic, or you can say better time as compared to the bubble sort algorithm. So I'm just going to go to build and run. Now you can see the bubble sort functions took 2 milliseconds to execute, and the improved bubble sort function took 0.00 milliseconds to execute. Okay, so that is done very that is very quite easily done here, and you can clearly see what is the difference between the bubble sort algorithm and the improved bubble sort algorithm. So if you want to implement this code, this entire code will be available with you in the files in the folder of this video. Okay, and you can execute the code on your machine, and if you want to make the changes more drastic, you can just try to increase the size of the array, try to increase the values which are stored inside this array, and then you can also implement find out what is the time taken on your machine to implement this function. Okay, now we'll do one thing. We'll take all these algorithms one by one. We'll take the selection sort, we'll take merge sort, we'll take quick sort, and we'll try to see what is the time taken to sort these array with these different algorithms. Okay, I hope this is clear. So let us move on to the next algorithm, and that next algorithm will be the selection sort and the merge sort algorithm. And for that purposes, I'm just going to consider the improved bubble sort algorithm. I'm not going to consider the bubble sort algorithm. Okay, so to compare with those algorithms, fine.